Front-end architecture has historically relied on splitting design systems into two entirely different languages. Human-readable style guides serve as the repository for design reasoning. They capture the emotional intent of a brand and the logic behind typographic choices. Machine-readable configuration files handle the execution. These are lists of technical values, hex codes and pixel dimensions, divorced from the why of the design. Over time, these layers inevitably drift apart. The technical tokens are updated in the code, while the prose documentation remains static, breaking the link between the design intent and the final product. This creates a significant hurdle for AI agents. When an agent attempts to generate a UI from fragmented context, it often produces arbitrary results that ignore the core system rules. Without a unified source of truth, an autonomous agent lacks the framework to map semantic intent to technical output. The Design.md open standard addresses this by creating a single architectural bridge. It merges the descriptive style guide and the technical configuration into a single Markdown document. This provides agents with a persistent, structured understanding of how a design system is supposed to function. The file acts as a machine-readable contract that agents reference to make informed design decisions. By unifying reasoning and values, Design.md establishes the necessary ground rules for autonomous UI generation across different tools. Inside a Design.md file, the structure is clearly divided between metadata and descriptive text. The specification introduces a dedicated token section to hold technical values. This section requires that reasoning and specific values live in the same block of context. You might find prose describing the voice of a site and the desired feeling of its typography. Directly alongside that prose, the token defines the technical constraint, specifying the exact font family and size. An agent ingesting this file processes the aesthetic goal and the technical data simultaneously. Providing this dual context helps prevent the agent from making choices that deviate from the established design system. To make this work, the specification shifts away from the traditional concept of a variable. Here, a token is defined as a named decision or a role. It describes a purpose rather than just a fixed value. Consider typography. Body main is treated as a semantic slot for the default copy on a page. That slot is currently filled by Noto Serif at 18 pixels, but the role itself remains the constant reference point for the agent. The specification establishes baseline roles that must be present in every single file to ensure a predictable structure. The primary role is defined as the main ink or text color used across the interface. The neutral role defines the background or surface colors that the user is emotionally neutral toward. Focusing on roles ensures that an AI understands the function of a design element before it applies a specific color or font. This role-based logic extends into the component section, which is currently an experimental part of the spec. Look at the background color property defined for the primary button. This property points directly to the top-level primary role rather than an isolated hex code. This allows for nested component states, such as a hover variant. The hover variant inherits the base button structure, overriding the background property to point to a different role variant. If a developer updates the primary role in the front matter, every component that references that role updates automatically. This inheritance structure ensures that the agent's technical output remains tied to the specific roles defined in the system's architecture. These structural roles are now formalized in the official Design.md specification on GitHub. Without a formal standard, different tools might generate incompatible versions of the file, leading to unpredictable behavior. The specification provides a core set of rules that any IDE or AI agent can rely on to parse the file correctly. While the core is strictly defined, the format is modular, allowing for custom extensions that suit different design systems. Formalizing the specification establishes Design.md as a reliable standard for programmatic validation. To support this standard, a new CLI utility allows tools to validate their Design.md files against the spec. We can see this in Anti-Gravity. An AI assistant is asked to add a new accent button to the design system. The agent makes a choice that looks correct, but technically violates a design rule, pairing a tertiary background with primary text. When the agent runs the CLI linter, the tool flags an issue. It identifies a WCAG contrast ratio violation. The chosen combination results in a 2.1 to 1 ratio, too low for readable text. The agent receives this feedback, corrects the pair, and passes validation. The agent now validates its own visual output against the spec's rules, without requiring human oversight. This system is built to work across the entire development ecosystem, not just a single tool. Because it is an open standard, Design.md acts as a portable contract that moves between different agents and IDEs while maintaining its full context. This has already led to community-driven repositories where these design systems are shared and refined. You can start using the CLI to validate your own files or contribute directly to the specification on GitHub. Standardizing this vital bridge between reasoning and execution provides a highly predictable foundation for future autonomous UI tools.